Hello, this is SCP question, chapter 1, Electrostatic. Number 1, what is electrostatic force? So F, force unit is a Newton, and the symbol is N. For the electric charge is referred to the Q, and the unit is a Coulomb, and the symbol is a C, capital C. Number 2, a positive charge Q is placed near the fixed charge Q. Let's say you have a fixed charge Q and you have another charge, the charge Q. See Q here, and if Q is moved away from Q, so Q move away from Q, describe the motion of the test charge, acceleration, whether zero, non-zero, constant, increase or decrease, and state your reasoning. So according to the Coulomb Law, F is equal to K, Q, and fixed charge Q over R square. Now F is inversely proportional to the R, so when the Q move, small q move away from Q, R is decreased. And what happened to the F here? When the R decrease, when R increase, F decrease. So according to the second Newton law, F is equal to MA M is constant. When the F decrease, A increase. F proportional to the A. So the answer is A is decrease because of F decrease because of R increase. And this is number B. Two equal charges, positive and negative, small distance apart, form electric dipole. A positive charge Q, as shown in figure 1, equidistant, that means the distance here is equal to the distance here. Describe all the force and the net force acts on the charge Q. So now this is positive and this is positive. Let's say you draw the distance here is equal to the distance here. So this is positive and positive, so the force acts on the charge positive Q here is direction is outward, because this is positive charge, this is positive, so this is repulsive, and this is positive and this is negative, the direction is attracting force. So now you have two force. The net force acts on the charge Q here is equal to, the direction is equal to here. So they say that's what this is F direction of the F net. Yeah. And this is number C, sorry. You have two charge, negative Q and positive Q, and the point P. Magnitude of charge negative Q is given by the equation. This is positive Q and negative Q, the magnitude, and calculate, number 1, calculate the net electric field produced at the point P when y is equal to 0. So say this is direction is y from the 4, the distance here, and x here is 3. So if you draw the triangle here, so this is 4, 3, and this is 5. So this is 3, this is 4, and this is 5 distance meter. And calculate the electric field, net electric field. So net electric field here, or EP here, is come from the positive Q and negative Q. So the first is E come from the negative Q. Negative Q is equal to equation K Q over R square. This is for negative Q. And the second E is come from the positive Q. Equation is K, the positive Q here, and over the distance is R square. So now the net force here, because this is negative, so direction is to the negative Q, and this is positive, so the direction is the direction of the positive Q. The question asks you calculate the net electric field. So the net electric field is just net here, E at P is equal to K Q over R square for the negative Q, and plus K Q over R square, and now K is constant, Q here is refer the magnitude is 3.2 times 10 to the minus 19 coulomb, and Q here is equal to the same value 3.2, R here is equal to 5, and R here is equal to 5, so the total EP here is equal to 1.38 times 10 to the minus 10 Newton per Coulomb. This answer for the number 1. And number 2, calculate electric potential. So equation for electric potential, V is equal to K Q over R. So V here at P here is come from the negative Q and positive Q. So V at the P, potential difference at point P is K. The sign of negative you must include in the equation to calculate the potential difference V. So negative 3.2 times 10 to the minus 19 magnitude over the distance here is 5, and V for the Q here is equal to K times 3.2 exponent minus 19, minus 19 over 5, and the value of V is equal to 0, because this is negative, this is positive, and this is all the magnitude is the same value. So V on P is equal to 0. Thank you.